Hello friends, welcome to today's artificial intelligence class, and in this class we will see the topic agent. So under this agent we are going to discuss the definition of agent, agent function, type of agents. And in the type of agents we are going to see the simple reflex agent, model based reflex agent, goal based agent, utility based agent and learning agent. And all these topics will come under first unit, problem solving. First let us see the definition of agent. An agent is anything that can be viewed as perceiving its environment through sensors and acting upon the environment through actuators. So this is an agent. Agents should have sensors and actuators. Okay, what is the purpose of sensors? Sensors are used to observe the current environment. What is presently in the environment, that will be observed by using sensors. Okay, perceiving its environment through sensors, right, and acting upon the environment through actuators. So accordingly, so based on the current environment, it will do actions by the actuators. So this is called as agent. So agent is going to perceive its environment and it will do actions on the environment by using actuators. Here let us see some examples for this agent. If it is agent, it should have sensors and actuators. Okay, so if it is a human agent, we can consider human as agent. Then the sensors are eyes, ears and other organs. Okay, those are used to observe the environment. Those are called as sensors. And actuators, by which it is doing some work on the environment. Legs, hands, mouth and other body parts, okay, which are used to do some action on the environment, are called as actuators, right. So sensors are used to observe the environment, actuators are used to do the action on the environment, right. Next let us see robotic agent. Here cameras, infrared are called as sensors, and the motors, those are used for doing some actions, are called as actuators. And normally all the input devices are sensors and output devices are actuators. Normally. Okay. The next one is agent function. Agent function is used to map the percept histories to the actions. Okay, so all the agents are having data set which contains the historical data, that is the perception histories of the environment. Historical data of environment. Okay, and it will map the current environment status. Of environment. So accordingly it will select action that will be performed on the environment, right. So agent function F is the percept history. P star means historical data. Based on the historical data and the current status, it will select the action. A means action, P means perception history, right. P means perception history, A means action. So based on the perception history plus current status of the environment, it will select the action that will be performed on the environment. This is called as agent function. So the agent program runs on the physical architecture to produce the function f. So what is the purpose of f? F is used to select the action, required action. By using f only we need to select the action. Hence agent, what is meant by agent? Agent is the combination of physical architecture and the logical program. Architecture plus program, that is physical architecture and logical program, the combination of these two will form the agent, right? Now let us see one example for this agent, that is vacuum cleaner world. Here our agent is vacuum cleaner. Okay, it will perform on this environment, so it is called as vacuum cleaner world. Here percepts are the location and contents. The location and contents. Here we are having two locations in this vacuum cleaner world. First location is A and second location is B. Okay, and what are the contents here? The contents are the dust or content. Okay, and action, what are the actions we are going to perform on this world? First one is left, that is turn left. The vacuum cleaner should turn left and vacuum cleaner should turn right and suck, that is it is going to suck this dirt, and no operation. So we are having four actions. What are the actions? First one is turn left and second one is turn right and third one is suck operation and fourth one is no operation. Okay, and we are having a tabulation of vacuum agent functions. What are the functions it is going to perform, right? First one is, this is the location and this is the content, right? A, this is currently the vacuum is in location A. Okay, A, and A is dirty. A is dirty means this one. Currently A is dirty. If it is dirty, then what action it need to perform? Suck operation. The dirt should be sucked by this agent. Okay, after sucking, what will happen? This location will be clean, right? There will be no dust. Okay, once A is clean, next that will come here. Okay, this is the first one and next this is the second. How the environment will be? Now the agent is in location A and the environment is clean now. Okay, now what action it has to do? Turn right. Okay, it will move to right side. The agent will now in the location B. Okay, and how the location is there? And this is the third one, B comma dirty. Now B having so much dirt. Then what action it needs to perform? If there is any dirt, immediately the vacuum cleaner should suck that dirt, right? So after that, what it has to do? And this is the fourth one, B comma clean. Now B is clean. Next it will go to left direction. Okay, this will move to left direction. Now how this A comma clean. Okay, if it is already clean, then there need not to be do any action, so no operation will come here, right? Our all actions have to be performed and our environment is already clean. If all the environment are clean, then need not to do any operation here. No operation will perform here, right? The next topic is type of agents. Here we are going to see 5 different agents. First one is very simple agent, that is called a simple reflex agent. and second one is model based reflex agent, goal based agent, utility agent, and the last one is learning agent. Let us see all these things one by one. The first one is simple reflex agent. So here this is the agent and this is the environment. Agent is going to perform on this environment. So first agent should have its own sensors and its own actuators. All the agents should have its own sensors and it will have its own actuators. By using sensors, it will observe the current environment, right? What the world is like now. So by using sensor, it will observe the current environment, that is observe the world. Okay. So after observing the current environment, and it is having condition action rule. By using the condition action rule, it will select the action that is to be performed now. Okay. Choose an action. So that action will be performed on the environment by using the activators, that is implement action that to be done on this environment. Okay, this is called as simple reflex agent. So this agent is having its own sensors and own activators. By using sensor, it will observe the current environment, and by using this condition action rule, it will select the corresponding actions that to be performed here. This is the very important concept in this simple reflex agent, and that action to be performed on the environment by using these activators. And there are some problems in this simple reflect agent. If the environment is not fully observable, we cannot predict the correct action. Okay, the action, that is the environment, should be fully observable here. If it is not, then the prediction action is somewhat difficult here, and it is depending on performance metric that may be inefficient. Okay, so these are the problems in simple reflex agent. And this is the simple pseudocode for simple reflex agent. The function simple reflex agent of percept, that is it will accept the percept, that is input. It will accept the percept input given as parameter of this function, and it will return action. Action is our output, and static variables are rules. Rules are nothing but a set of condition action rule, right? So that is static, and it is having three variables. First one is static, rule, and action. For this static, it is having one method called interpret input of percept, and this will generate the abstract description of current status. That is, the current state description will be given to the state. State is going to give the current state of environment, right? So based on the state, and the corresponding rule will be mapped, that is rule match. This rule match method that will return the rule that matches with the current state, right? That rule will be stored to the variable rule here. And rule action, this is the rule action that will return the action that matches the rule, right? The corresponding action will be given to the action variable, and that action will be written here. Here it is very limited intelligence because lack of fully observability. If the environment is fully observable, then the output will be excellent, otherwise it is not that much intelligent here. The current decision can be made only if the environment is fully observable. For example, we can take automated taxi driver, and this is if it is a simple reflex agent, then behind a car it would either brake continuously and unnecessarily or never brake at all. Okay, so we need to observe the entire environment, front side and back side of the car. If it is not fully observable, then we will get only the partial output. And next we will move to vacuum cleaner example. In our vacuum cleaner, if it is a simple reflex agent and it would observe only the dirt sensor and not the location sensor. So for this vacuum cleaner we should have two sensors, dirt sensor as well as location sensor. If there is no location sensor, and it will only percept dirt and clean, okay, and it will not move left side or right side because we don't have the location sensor. If the location sensor is absent means we cannot move the vacuum cleaner from one location to another location. So if it is a simple reflex agent, the environment should be fully observable. It should be fully observable. The next one is model based reflex agent, and this is the advancement of simple reflex agent. Here the additional information we are having the internal state updation, okay, that is the state of environment, all the state of environment, how the world evolves and what my action do, that is if I do a particular action how the environment will be. So all these things will be stored internally in the agent, okay, that is what the world is like now. And with those information, with those information it will select which action to be performed at this state, that is the current state, okay. So this is model based reflex agent, that is the model of environment will be stored in the agent, right, in the database. That is updating the internal state information, that is the information about how the world evolves independently of the agent. Without agent how the environment will be, that is all the state of environment will be stored there, and the information about how the agent's own action affect the world. For we are having a list of actions, a list of action for all the actions how the environment will affect, and model of the world. All these information will be there in this model based reflex agent. And now let us see the drawbacks of simple reflex agent. Suppose when we come to vacuum cleaner agent, suppose moving has a cost. For example, we need to move A to B. This is A block and this is the B block, okay. And if there is a cost of moving from one block to another block, what it will happen? Because in simple reflex agent there is no such cost information. And if a square stays clean, if the square is already clean, 1 second we need not to clean, isn't it? Then the algorithm will be extremely inefficient. Which algorithm? Simple reflex agent algorithm is inefficient if the square is already clean. We need not clean the same square again. So we need some improvement in that algorithm, that is we need to record when we clean the square and don't go back once we have cleaned both, okay. So each and every state information should be stored in the agent data set, right. So we have built a very simple model, handles partial observability. Which model? This model based reflex agent will handle the partial observability and updating internal state information. So we need to update all the internal state information, that is information about how the world evolves independently of the agent, information about how the agent's own action affect the world, and model of the world. The next one is goal based agent. Goal based agent means the agent should know the goal state of environment, that is the final state. So it should have some additional information about the desirable situation of the environment. So it needed the single action cannot reach the desired outcome, so a sequence of actions are necessary here, and therefore the performance measure needs to take into account the future. That is, after every action, the current state will be compared to the goal state. Okay, whether we reach the goal state or not. If goal state is not reached means again we need to select the next action to perform on that environment, right? And this is a typical model for searching and planning. So this is very important agent for searching and planning problems. Here the current information is not enough and goal information should also very important for this goal based agent. And this is the goal based agent. Here we are having some additional information about what it will be like if I do action A. For all action, how the environment will be, that will be stored in this agent itself. Accordingly, that will be compared with the goal state. Based on that only we will select the corresponding action that should be performed on the environment by using the activators. So this is called as goal based agent. So in the goal based agent, after every action, the current state, that is the state, will be compared to the goal state whether we reach the goal or not. If not, then we need to select the another action. That action should be leads towards the goal. The next one is utility based agent. In this utility based agent we are having the utility function. Okay, the utility function is very important. That is used to decide how happy I will be in such a state. That is, after performing this particular action, whether that will give me happiness or not. That is, by using this utility function we can select the better action to reach some state that to achieve some utility. Okay, for this particular agent is very much helpful when the problem is having more number of solutions and more number of ways to reach the solutions. Okay, so these more number of solutions, that is, all the solutions are nothing but the utility. So here more than one goal may be there in some problems and more than one way to reach that. That is, this is the starting state and more number of goal state may be there for some problems and more number of ways may be there to reach a goal state, right? And here we need to select which is the better one and more desirable than other methods. So for this purpose we are using the utility function. So which is the best way to reach the goal state and which capture the notion of better, that is better action. Which are the better action to perform to reach the goal state. Hence, utility function maps the state or sequence of states to a metric to reach the goal state. Okay, so this is utility based agent. The next one is learning agent. This is very important agent. This is unlike the previous agent. That is, the previous agents are used to select the corresponding action based on the current environment state. Okay, those are used to select only one action based on the current environment state. But unlike the other agent, learning agent is having some methods and they are performance element, learning element, critic element and problem generator. The first one is performance element. It is having some previously described actions and the corresponding changes in their state. That is, the action should change the state and those states will be stored in the performance element. And next one is learning element. This is very important element here. By using the previous experience, it will do some changes in the actions. And critic element is there. This is used to evaluate the actions and give the feedback to learning agent. So based on the evaluation of action, that will give the feedback to learning agent, and this learning agent will learn from this feedback. And next one is problem generator. It will suggest the corresponding action that to be performed on the environment. And this is the learning agent. Here this agent is having the performance standard. This is the historical data, and these are error free and correct data. So based on this data only, the agent will learn the current situation. And as usual, this agent is having sensor. This is going to sense the current state of this environment, and that is given to the critic element. Okay, and this current state is compared to the previous performance standard by this critic element. That is, the critic element is used to compare this current state with the historical data, and it evaluates the action and given the feedback to learning element. Okay, the learning element will use this feedback and it will accept the performance element knowledge. Accordingly, it will do some changes in the action. It will suggest the actions to this performance element, and it will give the learning goals to the problem generator. Okay, the problem generator will generate the action, which action to be performed, and that data will be given to the performance element. That action will be performed by the activators on the environment. Up to this we have seen the definition of agent, agent function, types of agent. So in this type of agent we have seen simple reflex agent, model based reflex agent, goal based agent, utility based agent and learning agent. And this agent topic is very important topic in first unit. You can expect 10 mark question or 5 mark question from this topic, and definitely 2 mark questions may also come from this topic. That may be either the definition of agent or any one of the type of this agent from 2 mark questions. Okay, students, please write the answer. Define the artificial agent in the comment box. Okay, all of you try to write this answer in this comment box. Thank you.